Hello, class. So we are in the middle of chapter 3 right now, section 3.4. And this section is about rational zeros of polynomials. All right. So in the last section, I kind of alluded to we're going to be using synthetic division to factor polynomials and find all of the zeros, right? And I kind of just used one, like I guessed the number 1 as an example, and I told you I would teach you how to know what to guess. Well, that is now, okay? So there is something called the rational roots theorem. All right, and that is what we are going to use to guess, okay? So I'm going to write down what a polynomial is, again, for I don't even know how many times I've written this down, but a lot. And so recall this is a polynomial, okay, dot, 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 a1x plus a naught, okay? And remember how the first term, the leading term, we always say is important, okay? And the constant term. All right, this is kind of why. Because rational roots theorem, okay, says that every rational root of a polynomial are 0, right? Roots are zeros, or like the same word. So every rational root of p of x is of the form p over q, all right, where a sub n, the leading term, is q, and a sub 0, the constant term, is p. And we mean all of the factors, okay? So we're going to use this idea to know what to guess, okay? So let's start off with an example. Okay, so p of x is, in this case, is going to be x cubed minus 3x plus 2. Okay, so q is the number 1, and p is 2. So to do rational roots theorem, we normally form p over q, and it's this set, because we're talking about factors here. Okay, so p over q, so q is 1. Okay, so we're just going to have, right, plus and minus 2 and plus and minus 1. Okay, and then like I could, there's q. Q is on the bottom. It's doing 1. Okay, all right. So that means I have 4 options, right? I have minus 2, 2, minus 1, 1. Okay, these are the 4 options to be rational roots of this polynomial, which means if this polynomial has rational roots, they can only be this. So this is what I'm going to use as my guesses. Okay, so now, you just guess. Okay, so I'm going to guess 1 because that's pretty much what I always guess first. Okay, so then we're going to do synthetic division. And look, it works. Okay, so then we can factor p of x, right? So p of x is going to be x minus 1, and then this thing. So x squared plus x minus 2. And then we don't even really, right, if this is a quadratic, okay? So we don't need to do rational roots theorem again, but we could. But when you get to the quadratic equation, that one you should just factor like normal, okay? And ta-da, there we go. Okay, so p of x fully factors into this thing, and the zeros are 1 multiplicity 2 and negative 2. All right, so now let's do a slightly more annoying example, a slightly longer example. Okay, so here I have a polynomial, p of x, and it's going to be 2x cubed plus x squared minus 13x plus 6. Okay, and the question is find all the zeros. Okay, so, right, 2 is q, and p is 6. Okay, but now these have multiple factors. Okay, so p over q is going to be, so q is 2 and 1, right? Those are the factors of 2. P can be 1, 2, 3, and 6. Okay, so P over Q is every combination of that. So I have plus minus 1, plus minus 2, plus minus 3, plus minus 6, but also plus minus 1/2, plus minus 2 over 2, but that's 1, so we don't even write that one down. Okay, 3 over 2, that one's new. And then plus minus 6 over 2, but that's 3, so we don't write that one down. Okay, so here we go. Let me actually do the work with that, just so you guys can see it. So I would do 2 over 2, but that's equal to 1, so we don't need it. And then plus minus 3 over 2, and then plus minus 6 over 2, but that's 3, so we don't need that one. There we go. So we have 2, 4, 6, 8, 10. We have 12 options here. So that's like a lot to guess, right? So, just, start guessing, okay? So really, from here, there's not much you can do, okay? So I'm going to guess 1 because I always guess 1. Okay, so 2, 1, minus 13, 6. 2, 2, 3, 3, negative 10, negative 10, negative 4. So 1 is not a 0, okay? Then I'm going to guess negative 1, and here really personal preference, all right? I'm going to guess the easiest numbers first, and then just keep getting more and more painful. So negative 2, negative 1, 1, negative 12, positive 12, that's 18. So both negative 1 and 1 don't work, okay? So then I'm going to guess 2. 2, 1, negative 13, 6. Okay, so 2, 4, 5, 10, negative 3, negative 6, 0. Okay, so 2 works. All right. And a professional tip, let's pretend that I got a plus 6 here. Okay. If you're just off by a minus sign at the very end, then guess the opposite sign of that number, right? So if I had gotten a plus 6 here, I would have just switched the sign to a plus 2 or something, okay? But so P of x equals x minus 2, 2x squared plus 5x minus 3, okay? And then because I don't want to do rational roots theorem again, I'm just going to factor it. So this one's a little annoying to factor though. So 2x and x, and I want to get a negative 3, but a positive number. So I'm going to guess plus 3 minus 1. And let me check. Yes, okay. So, ta-da. All right. But if you wanted to, you could have kept going. All right. So what I mean is, at this step, I could do rational roots theorem with this and write Q is 2, but P is negative 3 now. So it's at least a little bit less bad, right? I only have 1/2, 3 over 2, right? So I'd only have 8 guesses instead of the 12 here, all right? And actually, right, because I tried 1 and negative 1 already, really not to pick those. Okay, so really you only have 9 guesses. So I would have guessed 3 immediately, and then I would have seen that, oh, I should guess negative 3. Okay. All right, you get 1/2, negative 3, 2. And those are the zeros. All right. So that's rational roots theorem. Okay, it's very useful. However, it's not like bulletproof. What I mean is, here is this polynomial, okay? So this is a difference of squares, okay? So we know this factors into this, right? So we know the zeros here, okay? And if you didn't know that, complete the square or quadratic formula. But we know the zeros are square root of 2 and 2. And from the very first day of class, you know that these are not rational, right? Both of these are not rational numbers. So rational roots theorem, though, doesn't tell us that, right? Rational roots theorem, just we get a p and a q. So q is 1, p is 2, so we would just do plus minus 1, plus minus 2. And then you would plug in all 4 of these, and it just, all of them wouldn't work. All of these will not work. Will work, no. Will not work. Okay? So, you got to be a little careful with rational roots theorem, okay? Because sometimes the polynomial just doesn't have rational roots, okay? So then you have to do other things, okay? But if it does have rational roots, it has to be one of these, okay? All right. Now, really, I'm gonna teach you this fancy trick here now, okay? This is probably not very useful, if I'm being honest. All right. It's called Descartes' rule of signs. Okay. So, right, we saw here that I guess two wrong numbers first, right? It would be good if I had known how to guess better, right? So Descartes' rule of signs is like extra things you can know to help educate your guesses even more. Okay, so we need a polynomial, okay, with real coefficients, which that's going to be what we deal with all the time. So it always works, okay? So a polynomial with real coefficients. So okay, here is the rule. It's pretty long, but the number of positive, okay, real zeros of a polynomial, okay, p of x, is either equal to the number, I'm going to use this, the number of sign changes, okay, in p of x, or is less than that by an even number. All right, even whole number. So you can read the notes on this too, maybe the typed notes. But that's rule number 1, which is a little, you need to unpack that, right? Rule number 2, okay, is very similar though. So the number of negative zeros is either equal to the number of sign changes of p of, and then here's a big deal, p of negative x. Okay, so you got to do a little bit more work here. P of negative x or less than that by an even whole number. Okay, so here's how it works. Okay, so let me just use an example because that's some serious math that I just wrote down. Okay, so p of x, I'm going to have a 6th degree polynomial, okay, plus 3x cubed minus x minus 3. Okay. So, right, 3 is positive. Okay, so when I'm going to use Descartes' rule of signs, I look at the signs. So this goes from plus to plus to plus to minus. Okay, so this is a sign change. Okay, so whenever the coefficients flip from plus to minus or minus to plus. But then this minus to minus, that's not a sign change, right? This stays the same. Okay, so P of X here has one sign change. All right, which implies P of X has exactly one positive real zero. Okay, and so that's useful because, right, we know that this polynomial has 6 zeros, but only one of them can be positive. So when we're doing our like rational roots theorem thing, right, if we know 5 out of 6 of them are either imaginary or not positive, right, that means we should be guessing negative numbers. Okay, so that's how you can use Descartes' rule of signs to guess a little better, is if you look at this, you know you should be probably guessing negative numbers. Okay, and right, it's not like I didn't have to do serious math here, right? I literally just stared at it, looked at when the sign flips, and then I knew that there's only one real zero. So it's like a really fast thing that if you just memorize it and becomes instinct, it could be helpful. All right, it's just no one ever does memorize it and no one uses it. Okay, but now I'm going to use the other one. So that's rule 1. This was me using rule 1 of Descartes' rule of signs. Let me use rule 2. Okay, so this is P of minus X. So here I'm going to have 6x, okay, minus 5x to the 5th minus 3x cubed plus x minus 3, right? When you plug in the negative x and you have the odd powers, right, it comes out. So now I look at this thing's sign change. So I go plus minus, that's one sign change, minus minus, minus plus, that's 2, plus minus 3. So there are 3 sign changes. Okay, so that means P of X has 3 or 1 negative real zeros. Okay, so again, this means that I could have 3 negative zeros, but I could only have 1 real zero. Okay, so you should probably be guessing negative numbers. Okay, all right, and I actually don't know if this thing factors. Let me try. This is off the script. All right, so P of X, what is P of X? 3x to the 6th plus 4x to the 5th plus 3x cubed minus x minus 3. So let me try and do this, okay? So if we were doing rational roots theorem, full disclaimer, this could totally blow up also, okay? 3 1/3. So if I do rational roots theorem, here are my rational roots, right? Because you get 3 and 3, right? So I'm gonna guess -1. Okay, just this because I should be guessing negative numbers apparently. Oh, but I'm missing some stuff, right? So 4. So I don't have an x to the 4th power. I also don't have an x squared. Okay, so very important that you get those zeros in there. Okay, so 3, -3, 1, -1, -1, 1, 4, -4, -4, 4, 3, 3, -3, not 0. Did I do that right? Negative, positive, negative, negative, positive. That's definitely positive. Negative, negative, negative. All right, so what that tells me is I actually should have actually just guessed 1 because 1 is magically, 1 is the 0. 1 is the only positive real 0. Okay. So 3, 3, that's 7, 7, 7, 7, 10, 10, 10, 10, -9. What? I've lost my marbles, ladies and gentlemen. That's also not 0. What? Have I gone crazy? I might have gone crazy. Excuse me. Let me guess 3. What happens if I guess 3? 3, 4, 0, 3, 0, -1, -3. I'm gonna guess -3 actually. Okay. So 3, -9, that's going to be -5, which this is gonna be 15, which this is going to be a number that I definitely need to plug into a calculator. I believe that's 45 though, if I'm not wrong. No, I'm not. Okay, yeah, 45. Okay, so -45, which would get me a positive. That's not a 30. -45, and that's a 3. Okay, so -45 plus 3 is -42. All right, and I think, yeah, I think it's pretty obvious that this is not going to work. Interesting. Is it 1/3? I really don't want to guess a third. All right, ladies and gentlemen, it's time to cheat. Okay. By cheats, I mean I'm going to double check if this has rational roots. So let's go to our favorite website known as Wolfram Alpha. Okay. And let's see how this is going. So minus x minus 3. All right. Do you have rational roots? Are they just the fractions? Nope. You do not have any rational roots. Okay. No rational roots. All right. So yeah, I would have had to have guessed all 9 of these, and they all would have not worked. Okay. So maybe this is why I didn't finish this example. All right. But there you go. All right, another example of something that just doesn't have rational roots. All right. Okay. Now, let's do maybe one last example. Okay, but really this is it. This is the entire section. All right, it's just rational roots theorem. Okay, and now you can use rational roots theorem to factor polynomials. Okay, and then here's also where you just have to trust me, right? If I give you some big polynomial and I ask you to fully factor it or find all the zeros, that means I have actually double checked that it has rational zeros that you guys can get the answers to. All right. For example, like I would not put this on a test because this one didn't have any rational zeros, so you wouldn't be able to find any of them. Okay, but something like this looks really bad, but as you're about to see, this actually has very nice answers. Okay, so Q is 2, P is 9. So by rational roots theorem, I have plus minus 1, plus minus 3, plus minus 9, plus minus 1/2, plus minus, okay, wait, I gotta be a little careful here. No, I don't. 3/2, plus minus 9/2. Okay, yeah, there we go. There we go. So we have 12 again. We have 12 rational roots. Okay. And we want to guess. Okay. So as always, as is standard for me, let's guess 1. Okay. So 2, 2, 7, 7, -1, -1, -15, -15. That's going to be -9, -9, 0. Okay, but I have a 5th degree polynomial. Okay, so I'm just going to keep going. I'm not going to factor it. Like, I'm not going to write this down every single step. Okay, I'm going to try and find another rational zero right away. Okay, so I'm going to guess 1 again, because 1 could have multiplicity. Okay, so I find like a really bad trick question or a mistake students will make is just because I know 1 is a 0, they will never guess 1 again, and then they'll get stuck. Okay, you should guess 1 again because it could have multiplicity. Okay, so I'm gonna 2, 9, negative, just kidding, 9, 8, yes, 8, and then that's 7, negative, so negative 7, which means negative 7, which means this is not 0. Okay, so 1 is only a 0 once. Okay, so now let me guess negative 1. So 2, 7, 1, negative 15, negative 9. Okay. So I'm going to remember that 1 is a 0. Here, so 2, negative 2, 5, negative 5, negative 6, 6. That's going to be negative 9, which is 9, which is 0. Okay, so there we go. Negative 1 is another 0. And right now I have a cubic, right? Because I have degree 5, and I found 2 of them. So I need to find 1 more before I get the quadratic, and then I can just factor like normal. Okay, so I'm going to guess negative 1 again for the same reason. Okay, so 2, negative 2, 3, negative 3, negative 9, 9, 0. So there you go. Negative 1 is a 0 with multiplicity 2. Okay, and now this is my quadratic. Okay, so P of x right now I know is going to be equal to x minus 1 from the first thing, and then x plus 2 squared, because I found them twice. And then whatever this leftover is, so 2x squared plus 3x minus 9. Okay, this thing, you know, it's a quadratic, factor it, right? AC method, quadratic formula, complete the square, whatever you want. Okay, you're going to get 2x minus 3 x plus 3, and there you go. Okay, and then one thing I want to make a big deal about is what question am I actually asking. So here I didn't even ask the question, but if the question was to factor p, then this is the answer. Okay, I fully factored it. Here we go. If the question is what are the zeros, then the answer is you have to list the zeros, right? So 1, negative 2 with multiplicity 2. Okay. What's this? That's gonna be 3 over 2. 3 over 2. And then this one's gonna be negative 3. Okay. So if the question is what are the zeros, then this thing, this bottom one, is the answer. Okay, not the factored version. Okay, and as you see, it had all rational zeros. So like eventually, like if I had synthetically divided by negative 3 here, because you just like synthetic division, it would have worked. Okay, negative 6, negative 3, look, see, 9, 0. And then you would have gotten it anyway. Okay, so you can keep synthetic dividing, I guess, if you really want, right? If you don't want to factor a quadratic. But there you go. All right, so that's this section. All right, it's pretty important, okay, because this section is what teaches you what numbers you can guess when you're trying to factor a polynomial. Okay, it's rational roots theorem, P over Q. All right, and then you just synthetic divide all the time. Okay, Descartes' rule of signs. Maybe I'll ask you a homework question about it, but honestly, it's not too much to worry about. Okay, the main thing you want to worry about is, can you do rational roots theorem? Okay, that's it for today, guys. All right, see you next class.